Hello, algebra students. Mr. Lawrence here with your next FIP lesson, and today we're going to be talking about solving compound inequalities. That is, inequalities with two parts to them. Many of the things we do in this chapter are going to have two parts. You want to remember there are two parts. All right, now, the two parts are a part of the same problem. So make sure that you're thinking about the problems as one problem, even though they have two parts. Did I mention that they have two parts? I sure did. To help you out in the video, I've made the problems color coded. So problem one is blue, and notice it has two parts. All right. Well, let's see here. First, before I actually do it, I want to discuss the meaning of and. And means both. So when we solve this blue one, because it's an and statement or an and sentence, both parts are going to have to be true. We're looking for all the numbers where both parts of the inequality are true. Both must be true, okay? Or means only one of. So this inequality is or this compound inequality. When we solve it, only one half of it has to be true at a given time. So this first half here, this 3x minus 1 greater than 11, I'm going to find all numbers that make that true. Then I'm going to find all numbers that make 2x plus 5 less than 6 true. And my solution set will be all of the numbers that make the first part true or the second part true. And we'll see how to represent that, and I'll explain more in a minute. All right, well, let's get down to solving. This is just, we're going to solve it just like we would a normal inequality. And we're going to get 4x. It's going to be less than 16, and then I'll divide by 4. And then x is going to be less than 4. Now, if I get a number line out here, hold on a second. Actually, I'm just going to draw a number line. Oh, and I'm not ready to graph yet anyway. Let me solve the other part. I'm going to add 7 to both sides. And I'm going to get x is greater than 2. I need the and in there, very important. Here is my answer, not just one part of it. Now, what do you need to show on the number line? Some of you are going to waste time putting 15 numbers on this number line. No, absolutely not. I'm going to put the 2 on. I'm going to put the 4 on. If you want to put a number in between, you can. You don't have to. I typically don't because I know what numbers are in between. So the most numbers I want to see on a problem is 5 on a number line. Okay, don't waste your time making more than that. If you only want to make the 4 and the 2, that's great. Only make the 4 and the 2. Now, I need x is less than 4. The 4 is not included because there's no equal sign. And I need x is greater than 2. 2 is not included. Now, where are the numbers that make both parts true at the same time? Well, they would be in between here, wouldn't they? Yeah. For example, I could put 3 in. 3 is less than 4. And 3 is greater than 2. Okay, so what this is really saying is any number between 2 and 4, not including 2 and 4, because the inequalities don't have equals to them, will give me a true solution. I proved it with 3. I could prove it with 2 1/2, or 2 1/4, or 2 1/8, or 2.156, 2, 7, 3, 5, 4, 3, 1. I can also prove to you that the numbers out here, outside the shaded region, give you a false statement. They might make one part true, but since it's an and, it has to be both parts true. So for example, 5. Well, 5 satisfies this half of the equation. 5 is greater than 2, but over here, 5 less than 4, I don't think so. So 5 is not in the shaded region. Okay, let's try another one here. Tell you what, we're going to do one more and, just to reinforce that idea. So I'm going to solve both parts by subtracting 6 negative 2x is going to be less than 8. Divide by negative 2. Divide by negative 2. X is going to be greater than negative 4. And here I'm going to subtract 5. I'm going to subtract 5. X is going to be less than or equal to 12. Okay. So I need all the numbers that are greater than negative 4 and less than or equal to 12 at the same time. I'm going to show negative 4 will be an open circle, open point. I'm going to show positive 12, and that will be a closed point. Now, where are the numbers that make both parts true? I need the numbers greater than 4, but they also have to be less than or equal to 12. Yeah, they're right here. They're in between. Now, except for in one unusual circumstance, ands will always end up looking like a shaded middle part. If you take your hands, put them in front of yourself, make fists, but stick your thumbs out toward the middle. You should be looking at the back of your hands, and your thumb should be pointing toward the middle. Okay, now bring your thumbs together so they touch. That's what ands should look like. Okay, there is a rare case where you'll get like no solution for an and, but typically this is what ands look like, and I can demonstrate that in class if you can't visualize what I'm talking about. All right, now if I pick any number in here, I will end up with a true statement. I'll pick 0. 6 minus 2 times 0 less than 14. I think so because this ends up being 6 and that's less than 14. 0 plus 5 less than or equal to 17. 5 is less than or equal to 17. See, 0 makes both parts true. If I pick a number outside that region, I'm guaranteed to get a false statement. Pardon me, I will leave that to you to verify. Okay. Coming over here to the ors. Now remember, with an or, only one part needs to be true. We're going to show all solutions, but it's going to look a little different. So I'm just going to start solving, and I'm going to get 3x is greater than 12. Divide by 3, divide by 3, x is greater than 4. Or, now I'm going to subtract 5. 2x is going to be less than 1. Divide by 2. And then x is going to be less than 1/2. So I need all the numbers that are greater than 4 or less than 1/2. Well, I'll make my number line. I have to show 1/2. It'll be an open point. 4. Open point. Need the numbers greater than 4. They would be to the right of the 4, wouldn't they? And I need the numbers less than 1/2. They would be here. There you go. There you go. Pretty simple stuff. If I pick a number inside here like 0, I won't get a true statement. 0 greater than 4? Nope. 0 less than 1/2? Yes, it is true. Oh, I'm sorry, silly me. 0's not in between there. There's my mistake. How about if I pick 1? 1 is definitely between them. 1 greater than 4? No, it is not. 1 less than 1/2? No, it is not. So I've got a picture that looks like this. Now, ors will typically look like this. And if you hold your hands out in front of you again, but turn them over so that you're seeing your fingernails and you have your thumbs pointing outward. Some people think it's kind of like oars of a boat where your thumbs are the oars. Okay? Remember, oars only have to have one part of the inequality to be true. Now, number 4 here is going to be a weird case. I'm going to go ahead and solve it. 2x is going to be less than or equal to 12. Divide by 2, divide by 2. X is going to be less than or equal to 6. Okay. Add 5, add 5. X is going to be greater or equal to 0. So, or x is greater than or equal to 0. Now, Remember, I need all the numbers that are less than or equal to 6. Well, wouldn't those numbers all be contained here, right? And I need all the numbers greater than or equal to 0. Well, wouldn't all those numbers be here from 0? And see, I'm not going to stop at the 6 because only one part needs to be true in an OR. So 7 is greater than or equal to 0, so it needs to be in the solution. I'm not going to stop at the 0 because like -3 is less than or equal to 6, so it's part of the solution. So what ends up getting shaded? It looks like it's the entire number line to me, which means this one is all real numbers. Any number you want for x satisfies the whole thing. Um, the, both parts, or at least one part of the inequalities. And remember, in an OR, I only need one part to be true. All right, ladies and gentlemen, that is your video lesson for tonight. You can tell I'm yawning. It's actually quite early in the morning, almost 7 o'clock, but I'm running out of gas. Mr. Lawrence signing off. Good night, everybody.